Hope you are able to see my IntelliJ idea.
Yeah.
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 So let us continue some example of your synchronized keyword, right? So let us same problem we are going to the continue today. Like yesterday we did producer and consumer, right? Producer
Right.
and consumers. So here we are going to implement this producer and consumer problem using the synchronized, okay, yeah, blocking mechanism. So if thread 1, like this is the producer threads and this is the consumer thread, right? Consumer
Right.
thread. So whenever producer producing data, so somewhere they are producing so that consumer can consume, maybe between the some shared object, right?
Right.
Shared resources. So here producer come and get and producing data here, right?
Right.
And once producer produce data and consumer go, hey, producer produce, the consumer go, okay, I am consuming data. And whatever I want to, maybe printing the print, right?
Right.
So let us here say ki I am going to producing data, here going to consuming data. So I want this thread want, let's say I produce data, then I am going to wait until consumer not consume them. Okay. Once consumer consume, they notify me, hey, I done my work. You go continue, right?
Right.
Today our objective, we are going to ensure that this block at a time only one thread can access, right? This is maybe there maybe this is the one object. They have a two operation. One to accept value, one to read value, right?
Right.
So that producer can send data and we can accept, and this data have some read method. They read value and the thread can read. So this object I want, this should be accessed by two threads, means at a time only one thread can access, right? So here we can say maybe synchronized keyword help us to ensure that the particular object at a time only one thread can access, right? And here I also think let's keep this object able to access and produce data. And our objective after that, I am saying, hey threads, please wait. Okay. Now you wait. You don't know when second thread wake up and read data, right? Until you are wait until someone not notify you, right? This thread say consumer, let's consumer consume data. Then after that say, hey, notify. I done my work, right? So we are going to today understand this synchronized wait and notify methods. Okay, कि how we can say, hey, producer, can you wait? Or how I can say, hey, consumer, you can notify them is someone waiting for you, so that this wait threads can get notification, right? It's to clear the our problem. What we are going to do, our objective is that we are going to create one producer thread, one consumer threads. Both are accessing one common object. They may be, this is the buffer object, data object, list object, anything. Buffer means where you can store something, right? Any common object, shared object. Our objective second, ki this object we are ensuring that at a time only one object can access. And second, once one object access, after that those threads are going to wait. We are going to the call wait method. Wait is the method. I'm going to talk how can call wait method. And once waiting done, after maybe producer produce or consumer consume, they have to also notify, hey, I my work done. I am notifying any other threads are waiting. Let's come out, right? So have you remembered in the thread life cycle, whenever discuss, we have a following thread life cycle. One is your running state, right? Running, running state. Another ready to run. Okay, ready to run, running. And one is the not runnable stage, not runnable stage. And finally, one is the dead stage or terminal stage, terminated the program. So whenever one threads are dead running, and while running, we say wait. Wait means we are going to say, hey, go to the move and here wait. And wait until someone not notify you. So this thread is going wait until someone not give the notifications. Once he receive the notification, they are going to back ready to run, acquire the locks and start our working, right? So acquiring lock here, acquiring means we can use the synchronize for acquiring. We are waiting, we are going to the use the wait method, and someone notify you, we are going to use the notify function. So is it clear what we are going to do, right?
Yeah, I have a question.
Yes.
So when you open a thread,
Hmm,
or when you create a thread, like
hmm,
thread, new thread,
hmm,
and then you're trying to, you said you want to access this object, right?
hmm, hmm,
This object you're talking about.
hmm.
So it has a method,
Right.
right? Right.
Hmm,
So whenever you call that method, you
hmm,
only type thread dot start.
right.
But how does it, if the method has a different name?
Hmm. Always thread is the need. Not there is no any meaning of run or what. By default signature, your method name would be void, and notice your uh, whenever last to last class, whenever we teach about the thread class by default implement runnable interface, right?
Right, right,
Runnable interface, this is run method. Generally, we are
right.
writing code in run method. Run method is not required only run method. Any method that can have a syntax void and no input value. That can be
Oh, okay,
our
okay.
thread can call. Run is the not only always mandatory things.
Okay.
Only our compiler thinks syntax. Your method have a no return types and no input value. I can run.
That's the criteria. That's the
That's
criteria.
criteria. Notice last couple of way we can understand to you can create the thread, right? So let us
Mm.
example. This is the my method simple. Uh, Static void void test. Let's. This is the
Yeah,
my method name. They follow the same signature. Void none anything, no input, and this is my thread code. That's out. Okay.
right.
Let's int stream dot range. Let's give 1 to 10 for each system dot out dot println. Let's example.
Right.
And so this is now here say simply say now hey thread new thread, and here I can say pass. This is a test method you can call. Hey simple class have a test method and dot start. Now this your thread going to call this method,
Oh, okay,
right?
okay. I see. I
And
see what you
in
mean.
different
Okay.
thread, right? Simple run it.
Mhm.
So this is the way the run is a not a method name any important. Method name is not very important than just needs the signature. What this run method expect? Run method is you can call give me the any uh, uh, method signature which follow this rule. Void no input parameter. I can assume this is your code where thread can execute, right?
Mhm.
Even here you can say like maybe number equal to say system dot out dot println your number and plus thread name, okay.
So
uh,
you can type like that, sample colon colon test instead
uh,
of doing.
yes,
Okay.
tell me. I am just informing this ki hey same thread class, you need to run my code as a thread, right?
Mhm.
This thread class, if I'm not passing anything, let's say I'm not passing this, so they are run, but what the code they are going to run, let's say Press out. Main. Okay. Start. Started plus thread dot current thread dot get name. Started and completed.
Right.
If you run let me run. Notice thread started, main, and completed. They are not doing anything. Thread, right?
Right.
Because you are not telling, hey thread, what the code you have run in the separate thread. So I say, let's sleep duration of, let's see, 1 second duration of, let's 1 second. So each 1 second this thread going to run. Now until you are not passing here, if you pass here test, okay. If you pass directly here in this way, what this say, I am not able to call the method here, because you just give me the uh, test name, but just only I am going to call whenever thread going to start by the new thread going to the call your test method. Don't call me, right? So here simply say, okay, this is my sample class where this is my test method. This test method follow the same syntax as the run method, right?
Right.
And just run it. And now after that start, and notice the new threads started. Notice that new thread is started, right?
Okay.
They are
Okay.
doing different work, right?
Hmm.
So this no any kind of you can say hard or fast rule. You can say just convention. You can use a run method or test method or anything. A task method, you can say give me any name. Name is doesn't any make sense nowadays. Okay?
Right. Right.
Due to method reference, due to lambda expression, name is doesn't matter anything, right? Okay. Even this is the one way, right? Even you can use here lambda expression, right? In this way you can say, or you can say maybe directly here you can say no, I am just going to here and say lambda expression and simply going to here and call your test method. Okay.
Right.
Simple dot task. Okay. Method reference. Okay, same thing. You can write both ways. Simply this code or this code, both are the same. In IntelliJ support, why not call from method reference? Okay,
Okay. Okay. I see. I
so
see.
both
Yeah.
way you can do this. Okay? Notice this is the thread one started, two to thread is started, right?
Right.
Because this is the thread one, this is thread two,
Right.
right? Even you can pass your name ki thread one, thread two, whatever they were, right? Now both are run. Even here you can say, hey, my thread one, thread one, right?
Right.
My thread two, you can give the name if you want your name, right? Right? Now, this is the way. Basically, nowadays, this is not always be necessary to your method name would be run. But run is also good. So notice it, note thread one, thread two, thread three going on, right? Done.
Yeah.
Even you can, good way you can use the runnable. There is no any harms. Even you can say, hey, this is my runnable task. Okay. Task, task. And here you can say lambda expression. Similarly, code here you can write simple dot task. Okay, and similarly you can say
Okay. We
I
can do
can
that
start,
too
yeah, I can
because
start with thread 3.
runnable is the parent
Yes, notice here, and now here I can pass simply my task. It's also acceptable, right?
Mm-hmm.
This is the one way, this is another way. In this way, also the same thing you can do. Now we are passing the runnable object here name, right?
Right, right,
It's fine. Now three thread 1 2 3 started. So run. This is the your run method implementation. You can say.
right.
So how it's possible? Because this runnable is interface, and notice in the interface I can provide the implementation. No input parameter, and what is the output? This is my output, right? So
Mm,
this way, this is the simple way. So someone write this way, right? Both are the same thing, right?
right.
So any question?
Yeah, it's good. It's good. Can we also type like sample equal to new sample, then object of the
Because no,
class?
this is the static method. Yes, this is non-static method. Let's this non-static method. Okay,
Okay.
then let's static method always prefer way to call from the class name, right? And let's this is
Right.
non-static method. Okay, this way instance method, right?
Right.
Instance. Okay, task. Okay. Okay. So if you want to this, so you have to surely you cannot call like this way. New thread dot start. Here you cannot call like now directly because this is the unit object. The first you say sample equal to new
Right. Okay. Okay.
sample plus okay, and after that say sample colon this, right?
Right. That's okay. So that was my question. Yeah.
You can do here sample or a sample object
Yeah.
colon does that start. This way also you can do, right?
Oh, okay. Okay.
Whenever this is the instance method, then you have to need this object, test object, right?
It's called instance method.
Not static means
Okay. Okay.
this is need object, right? And this is the maybe you can give your thread name 4, whatever you want, right?
Yeah. Now the top examples would not work because
All
we
work,
changed.
all work,
Oh, all will work.
all work. This is also work. This is also work. This is also work. This is also work. All works. Okay,
Hmm.
because this is your not static method, na? So you always need object. So first create object and then say, hey, call them, right?
Right. Right. Oh, it's a non-static. That still work.
All work. Uh, even manually you can say, hey, no, I want to runnable only. So runnable one equal to you implement using the anonymous. This is also possible, right? Here you can
Right.
say, hey, already we have a this is the sample dot instance, and now simply you can also start this way using anonymous way. Now say, hey, this is the in this case I pass this. That's only this runnable.
Hmm.
This is also now here you manually implement runnable interface, run method.
Right.
It's also work fine, right?
Yeah. This is anonymous way.
Anonymous way, maybe implementation class way, but all work the same thing. All threads are started, right? And
Hmm.
maybe simply no, I am write my class way. Simply say class my thread, okay, and implements runnable interface. In this way, you can also so write
Right.
and here implement runnable interface. Here implement runnable and here let's call them, right? Now it's done and now say, hey, I going to start new thread. Here say, let's this is the my object. So here say new or here say thread, my thread equal to new my thread, right? And here you
Right.
can pass your own object, right?
Right.
Here you can say 6. Okay. This is also using class. It's also work. Even you can file implement runever you can do. So here run method is just syntax you can say. So notice all the 1, 2, 3, 4, 5, 6 are threads are running, right?
Right.
So notice here you can use your implementation class or direct runnable anonymous class or even the any instance method or any direct lambda expression or method reference. All are option you can whatever you feel easy you can do.
Right. Right. Okay. Hmm.
Even directly not runnable interface, even you can say I can simply say class my the thread class and just extend thread class itself, right? Okay, in this way. And here, same thing you can write here as well as, right?
Hmm.
Even you can extend or implement each, okay? And now here you can place your object, whenever my, okay? And same thing here, you can start your thread. For restarting thread, you need a task. Well, look, this is my class. So I can see the class, my class, and this is the 7 number of thread, right?
Right.
So there are multiple approach here. You can give the code which run in the thread, right? The
Right.
objective is that this thread class, you until you are not passing here the method, what the thread going to do, right? So here, what you can pass simply one class object, right? Here, like this way, you can write your
Right.
class, extend thread class, override run method, right?
Right. Right.
Or here you can pass the no, I'm not going to write a class. I'm going to only maybe implement runnable, not using the thread class. So I'm going to implement runnable, implement the same, and pass here object, right? Or
Right.
you can say even I'm not any class, directly anonymous class you can pass here and pass the object, right?
Right.
Or you can say no, I'm not going to even implement runnable. I have a simple one method already the follow same syntax like here, right? I can call this method as a thread, right?
Hmm.
Let's say, hey, this is my simple method, call them. So this thread constructor say, just give me the code which I can run. Uh, Code name means method. A method name must be follow this syntax, return type void, and task should be run.
Right.
If method name, let's take this is the input X. Okay. Now compiler is very, very unhappy because notice here compiler cannot call your code here, right?
Oh, yeah.
Because they know कि this thread class is the constructor, they are expecting runnable interface means कि method name would be void and return type void, input is no argument, right? So they
Hmm.
are thinking this way. So any method which follow this syntax you can pass here, right? So you can say
Right.
this task method you cannot call because they are expecting in some input, right? You can just remove them and it works, right? So any confusion how we
Yeah.
can create thread?
So let me recap. So when you, let's say that you are trying to run runnable
Hmm.
interface as a anonymous
Hmm.
way,
Right.
you
This is as
still,
anonymous.
yeah,
Yes.
anonymous. So in the line 31, you still have to put new thread, then you
Yeah.
have to put runnable
Always
one.
need the start method have only inside the thread class, right?
Oh, so it start comes from thread, not, yeah. Okay, got it.
And if you are going to use the last class, if you look using the executor interface, executor service,
Right.
this work new thread start method is done by Java library itself. Even you don't need to manually start, right?
Right.
So lots of implementation, but if you are using a new thread class and the thread class just need tell me which method I am going to work as a separate thread. You have to pass as a parameter here. The parameter you can pass as a complete your class that extend thread or complete class that implement runnable or maybe simply runnable interface or any method that follow the syntax of the run method or maybe lambda expression, maybe directly method call or maybe directly method reference. All are the possible way you have you can use. Is it clear?
Hmm.
That's good.
Okay. Now it's clear. Now we can look into some synchronized. Uh,
Yes. Oh, yeah, we are going to talk
Sorry,
about.
I diverted
No,
your
no, that's good. That's
attention to this.
always be uh, ready to understand the things. Until we not understand, may one time discussion, two time discussion, 10 time discussion is required. Always be ready to discuss. Okay.
Right. Yeah. Yeah. Thanks. You put it on the comment so I can review that later.
I'll
Uh,
just commented this code.
Yeah.
Okay.
Instead of deleting, it's
No,
better
no,
to.
I am. Whenever I commit this code, I will uncomment it. Okay. Just when I don't want to run all the things again and again. So let us come our original problem. We are going to understand how two threads are communicated with one shared object, and our objective we are going to use the synchronized object and note wait and notify, right? As example explain. Okay. Till now, any again doubt with our what the going we are to what the going we are going to create one thread, producer
Yeah.
thread, one thread, consumer threads, and one buffered object where one object maybe buffered object or anything, they have some space to write data, right? And they are getting first, this is the one object. So I am can say, hey, anyone going to call, first take the lock of this, right? Once you receive the lock, write data and go for wait, go for waiting stage, right? Waiting, and wait until someone not modify you. This thread come, acquire the lock here, and go inside, consume data, and after say, hey, notifying, means ki waiting thread again go up, right? Our
Right.
so this scenario you're going to implement, right? So let us here a good example. Let's I simply write one class, maybe producer consumer implementation, producer consumer implementation. Anything you can write, or okay, or simply say buffered. Okay, buffered. Okay, buffering where you can write some data. Shared object you can say, right? And here as let us we have a just I like I started discuss maybe somehow we have a one integer data. Okay, and here let's keep we have going to two method, one method produce, one method consume. Okay, so let's keep here one method public void and produce. Okay, produce method receive input x value and going to write in the data, maybe buffer data input whatever, right here. And another method here public void uh, void let's consume. Okay, consume just not receive anything, just consuming data. Okay, uh, consuming data. Okay, and let's here a constructor. Okay, constructor that take a your buffer size, whatever the buffer data we have. Okay, or maybe don't need any, just simple, so I simple. So now we have a one object name is the buffer, we have a one data, someone write and someone here read, right? And this should be public so that anyone can call them, right? It should be private. Okay, good. So here first things, whenever producer going to producer require the kind of a lock object of this. Here our objective, this is the producer, this is the consumer, this is my buffer, right? The buffer is my one object. The first producer going to produce data here, first acquire the lock of this object, right? Buffer is the object, and I started saying each Java object have a lock. So we say कि, hey producer, First you acquire the lock here. If you get the lock, then you can go and write data, right? Until you're not getting lock, just wait here, right? Once you write data, after that you itself go to the for waiting stage manually, right? Wait. So here I'm going to say when a producer come here, first, so last class discuss for getting lock, we have a two mechanisms. One is the synchronized keyword, one is the lock interface, right? So today I'm going to take example of synchronized keyword, and later maybe tomorrow we'll discuss the one example same using the lock interface, right? So let's keep, I'm going to the synchronized word keyword, okay? So synchronize object need a lock of which they need a some object where they're going to the lock, right? Object of, let's, I'm instead of data, I can just say here a list, okay? List or queue, you can say, you can use a queue, okay? You can use the queue of integer, okay? Okay, and here say maybe new okay. So I'm just okay. So we have a queue.
Uh, we
Just
have not done this before. This one.
you look like a list data structure, similarly queue data structure. Queue look like a this is the list where you can put some value and get some value. Also, let's simple
Oh,
list, I already list.
okay. Okay.
List, already list interface, right? Integer,
Yeah. Yeah.
a list of integer, and say, hey, this is the list, just new array list, okay?
Okay.
This is the one, okay? And this is the object. I am saying this is the where this producer going to write data and consumer going to read from list. It's clear?
Yeah.
So I can say if producer going to write data in the list, first get a lock of the list. Okay. How they get the last lots of lists. Okay. And suggestion should be final. Okay, let's go final. Okay. And here once they get a lock, that means now they are going to the check. If let's keep today our objective keep producer at maximum, let's add a or simple. Simply now we get the last, say producer say hey dot add method, because I can going to add the value in the whatever the x have value I am going to put here, right?
Right.
And after that I'm say I have to, if I, this is the producer is this is the our shared object getting the lock. Once you receive the lock here, they are going to write data here, and after that they are going to the wait, right? Say
Right.
here I'm going to wait. So this is the one method. Those is known as a wait. Wait method is are going to wait of you, right? It's clear. So now writing data, I'm going to wait. Notice this wait method from where you are calling. Wait method is defined in our object class. Notice this is the our object class. Object class is the super class of all Java classes, right?
Right.
I am so cute. But now I'm writing this buffer class. The buffer class by default inherited from your object class. If I'm writing any Java class, all Java class by default is the subclass of your object class. So
Right.
this method, wait and notify, these two methods are by default defined inside this Java object method. So I'm saying this is our list is the object. Here I'm acquiring the lock, and I done, and I'm going to wait. Means ki I'm releasing the lock, and I'm going to the non-reliable stage, right?
Right.
Because I write data, someone come and consume, right? And let's new thread come and consume data, and after that they hey notify, go to ready, right?
Right.
So this is the producer producing data, and similarly now this is a consumer. If consumer want to consume, then what's this thing? They also need a lock. So this is the shared object. I am saying, hey, I need the lock. So I need a synchronize. Give me the list lock. I need the log data. And after that, what can I say? I just consume. Consume is list.get, right?
Yeah.
This is the list my consume and list dot uh, remove. The one method get and one method remove. Remove means they are giving returning data and remove the value, because our
Right.
objective here list, if these threads are written data here, our objective I maybe read value and remove from the data here, right? I am consuming,
Right.
right? This is the one. If you can use the just get method, just get value is still preserved, right? So whatever the
Right.
business you want, you can implement, right? So here I am going
Right.
to say remove. Remove method what return? Remove this. I want to first position, right? First position data I want to remove from list, right? And this is a
Right.
remove object. Just say consume object. Okay, consumed data, right? So now here, this is the producer method which producing data. Consumer method consuming data. Look like very simple. And once consumer consume, that time say, hey, I consume, I am going to notify. Okay? I am going to notice, I am going to notify all. This method also is defined inside the object class. Notice this is the object class, super class of all classes, right? So these
Right.
two method in this notice here, this is the one notify method, okay, and one is the wait method. This these two methods are generally used inside the synchronized block. Okay, whenever you are going to call this method always need the lock of the object. So how to get a lock object? Using the synchronized keyword. So notice
Right.
first I am calling this method inside the synchronized block, right? The first rule, whenever you're going to the call this notify method or this wait method, we always call from the synchronized method or synchronized block, because they are required object lock.
Right.
And notice here wait have a one without parameter, one is the timing. What the number of time wait, right? This notification means ki whatever the thread noting waiting, I am going to notify them, right? So these two method notify or wait are defined inside the java.lang.object class, right?
Right.
uh, why? Because our multi-threading environment, our thread can wait any java object, right? Maybe wait buffer object, list object, linked list object, hash object, map object, my own class object, employee class object, right? Any object can be shared between a thread, right? So this wait and notify method must be available for the all the Java objects, right?
Right.
Due to this reason, Java designers are place this method wait and notify inside the object class itself. Similarly, like in this object class, we have a like method hash code method or method equals method. Notice each object have equals method by default, right?
Right.
How? Because they are defined inside their object method. Each object you can call hash code method. Hash code method by default is come from the java.object. So this is the uh, always we remember object is the super class of all classes in the Java. This is the super class you can say in Java. This is come under
Mm.
the java.lang package. It's clear?
Right.
So sometimes someone asks why this method were defined in the object class, right? Because
Right.
whenever going to the call object, we need a lock. Lock here you can pass object, maybe this object, maybe buffer object, maybe list object, any object. So each
Mm.
object must have a some wait method, right? Or even you can say here, maybe here good option you can say list dot. You can say list dot wait. In this way you can call both are the same thing. I would say hey, list dot notify. You can also call this way. Both are the same thing. Notice list class have a wait method. Why? Because list is inherited from the object by default, right?
Right.
In the list method, there is no wait method. In this way, you can say, hey, list, first get the lock of list class. I am going to add value some list, and after this, say, hey, I am going to wait for, right? So generally, you
Yeah.
can write this way or this way, both are the okay. So generally, someone say, hey, simple say, thread are going to wait in this way. Both are the same meaning, right? Okay, there is no. So till now, we have a two kind of works. One is the producer producing data. One is the consumer consuming data. Now let's the things. Uh, might be these two code. This I pass it, this code I pass from one thread. This code I call from another thread, right?
Yeah.
So question, might be this thread get first chance to run, right? Then what happened? They are going to get data from the list zero. List zero no have any data, right?
Right.
So we have to somehow, if list is empty, then you have to wait, right?
Right.
Might be this thread get a first chance, logically, best option. Then they are going to the put data, right?
Yeah.
After that, if this come, that's good option. They can get data. But I don't know which thread going to take first, right?
Right.
So we have to put condition here. Something, if our list is empty, right? No data, then you have to wait, right? So here
Right.
say, hey list dot size. Size is the one method. Okay.
Yeah.
If zero, okay, file until size zero. What you do? You just wait, right? It clear?
Mm.
Or this is the one method is empty. Size have a one method like empty. Is empty method same code written in the method, right?
Right.
If your list is empty, no data, just we wait, right? It's clear?
Yeah.
Similarly here, let's this list, what happened? This thread get a first chance, and in this list, they are going to put one data, right? And next time again, this take a same thread. So next time again, they are going to put data. So our objective, no, you can put only one data. Someone until not read, don't put new, right? So if this thread also we to check here, if thread already written in this data, until some thread not consume, I am going to the wait, right? So here
Right.
we have to set, hey, similarly like here, whatever doing here, here say if list dot size equal to one, right? That means you have to wait, right? Or
Right.
you already written one data here, right? So this is the check we have to apply because our business logic say we decided say whenever in before one data written by one thread until someone not read them, don't write the new data, right? So here
Right.
let's get a chance, this thread again get a chance, right? So what happened? They are going to again write the new data. I'm not going to test it to with new data. I'm saying if size already one means ki already you written data, you wait, right?
Right.
So one ID wave, once I data written, that means I say, hey, someone go to the notify, right? I'm initially if already written data, good. If no zero, that means simply say, hey, add all, right? If one already wait. So this check we have to logically as per business case, we have to apply here, right? And similarly here, similarly if you're empty, just read data and notify all, right? Is it clear? Here I am using the synchronize, wait, and notify function. So till now I have just written these two method. This is not till now. This is no any thread. Simple one class, and where I written my this logic, right? This is the producer. This is the consumer. So let's now I'm going to create two threads. In the one threads I'm calling this producer. One thread I'm going to consumer, right?
Right.
So again, to writing producer and consumer. Yesterday I write the class. You can write the class, or you can multiple way. Here we discuss. You can implement call start thread, right? So any one approach we can follow to start the thread, right? So let's simply here I am going to either simply for understanding I am write a class producer, right? Producer, okay, producer, okay. And
Right.
that implement runnable, okay. So that initially we should and override the method, right? Because whenever you are going to implement runnable interface, you have to i- implement this runnable method, right?
Right.
Clear? And this producer are going to the call this produce method, right? So let us say this means this required here buffered object. So here say this is the producer, similarly your consumer. See your consumer, right?
Right.
And how to start thread? We already know how to start thread, new thread, new threads, and here say, hey, you pass the new producer, right?
Right.
Dot dot start. You want to give the name here? Let's key comma. This is the producer thread, okay? Producer thread, okay?
Right.
Producer, okay? And similarly, let's start the new consumer thread.
So we don't need to mention the name of the run because
Optional.
it's optional. Okay.
Just for our understanding, you give the name, right? This is not
Right.
mandatory, right? Optional parameter. So here, both producer and consumer. Oh, this is the consumer. Okay? Both producer and consumer threads started, but what they're doing? They need to call this method, right? They need to call this method producer produce and consumer consume, right?
Right.
This method I written inside this buffer class. That means we have to pass this buffer object, right?
Right.
So let us say, hey, buffer equal to new buffer, right?
Yeah. Now we pass the buffer.
I can say, hey, this is your buffer and this is your buffer, right? So
Right.
those in this class also need a constructor, right? Okay. And this class also need a constructor, right? Constructor. Okay.
Right.
Here say this buffer. Okay. This dot mm, this dot buffer equal to buffer, right? Similarly, this thread as well, right? Okay. Okay. Till now,
So
okay.
these two needs the constructor.
Hmm. Because
Oh,
they need us because our objective thread 1 and thread 2 started, right? Producer consumer. Both need this buffer, right? So that they can
yeah.
call the produce method, they can call the consume method, right?
Yeah.
So this is the one object we sharing to the both. So whenever you say ki this is the thread 1 and thread 2, you want to share the some common object between the both, you have to pass as a constructor, right? Right? So here what we're doing? Here just we are starting two threads and both thread I pass one buffer object, right?
Right.
So now this buffer object they have. So in the run method, what say they? Run method say, hey, this is the producer that say producer produce, right? And produce
Right.
pass some value, right? Maybe let us example here say let's while let us I am going to the pass some number of maybe 10 number, okay? Let's say yeah, while loop or int stream loop, whatever loop I int stream dot range, and I'm going to 1 to 10, 1 to 10 number, right?
Right.
And here say for each number I'm going to call this number, okay? Whatever the I number, I'm going to call this as I, okay?
Right.
So this is the way I'm going to producing the number, okay? Okay, need a try catch. Okay, here say and simply here say let after producing one maybe I'm going to sleep for time, okay? Thread sleep dot sleep duration of let's say 2 seconds, right?
Right.
I'm waiting for some. So now this thread are producing 10 numbers, right? And but notice our objective, you cannot continuously produce the 10 item, right? If you get the lock of this thread one, okay, this thread another. If this get a lock of this, they are not going to continuously produce 10 number. Produce one and go to the wait, right?
Right.
Until someone not come and consume and notify you. Our objective. So here in this case, just I am going to produce. Similarly, this consumer is going to just consume 10 times. This is the buffer, okay? This is the producer code done, right? In this run
Yeah.
method, just call the produce method, okay? In the case of here, consumer, where is the consumer? Consumer, similarly, let's go into the column 10 consumer. This is the consumer. Here say, hey, let us, I am going to consume those 10 stream range 1 to 10, okay? And after that, I say, hey, for each, just I am going to say, uh, I, and I simply buffer dot consume. I'm just consuming and just write the done. Okay. Okay.
Right.
Here just a producer thread just producing 10 number, a consumer thread just consuming number. These two method producer consumer where I written inside the buffer. Buffer have a one common object, and here we are getting a log with given logic. If already one, just wait, and after waiting come, just notify them. Here say, hey, wait. If empty, until you're not getting data, just the consume data. Here just write one method produce data, right?
Right.
Right. Here say data producer added data in the list, right? So producer added data in list, right?
Right.
In list, okay? And just say what is the list, okay? Just a reference purpose, right?
Right.
And here consumer consume data from list. And once consume data from the list, and after that list would be become a zero, right? Because here I using the concept list dot remove. A remove method say I am going to what say remove method say remove the element at a specific position in the list and shift subsequent list to the left, okay? The by default they return give me the first data and after that they remove it. So this is the logic written inside the method itself, right?
Right.
We are just check RLS. This is the logic they written already. Remove data and remove the first, right? So I'm not going to consider here. Our logic is that here you can use the get method, any method, right? So let's test it's working as per our thinking or not, right? In the multi-threading, whatever you think, sometime it's not work as for you think, right?
Right.
Both case here. So I don't know which thread start first, which thread start close, but let's try run. And here I can just say completed. This is the line just start thread main thread started, right?
So this the one that we are learning, this thread, this is a very complex.
Not complex.
Mm.
I just this now thread is just a use case. What use case you decide to implement, right?
Right. Right.
Here all the logic depend upon the use case. What things you are going to implement, right?
Right. Right.
So here multi-threading is the program for your particular requirement, particular business, particular scenario. What scenario you are going to handle accordingly you have to write the logic, right?
Right. Okay.
Thread
I see.
thread is not say ki how to write the code. Thread say what your business you can do. Just give me the flavor how code run, right? Which
Mhm.
thread going to run your code? When they are going to wait? Where they are going to start working, right?
Mm.
Let's test it. Oh, something I am getting. What say? Illegal state current thread is owned by this. Where is this? Okay. What say they? Key now this buffer it produce. Illegal is the current threads is not owned. Okay. Here they say key lock. Okay. Get the lock of this object and list value. Here waiting stage, right? And again after waiting might be they release the lock, right? After you come, you again ask the lock, right?
Right.
Similarly here. So, okay. So here say ki in waiting state you have a get the lock and wait, and after that again come out, we take the again object lock and do and again notify them. Because here saying current thread is not his owner, right?
Right.
Again they are something, say producer produce data 1, and then producer say current thread is producer produce here. Now producer produce data. So what happened? Producer produce, consumer consume. Okay.
Oh, so they don't like notify all.
No, they are producer produce data 1, consumer consume. It's working, but next time why they not say again thread is not owner, lock is released, then again say lock is released. Now this is the object. I'm going to producer producing, consumer consuming. I'm getting the lock of this object. This is the object. We have a lock here. I am going to wait once consumer produce the producer data, and after producing, I have to, let's say, list dot notify, and here say list dot notify. Not one cycle work fine. Producer produce data 1 and consumer consume data 1. Okay, and after that they are very strange. Here say wait. Okay, again we have to wait on the list. Okay, list dot wait. List dot wait. Okay, and now producer producing, consumer consuming, producer producing, right? So in this way they are going to wait. So here let me just write the thread name
So
right
how
here.
did you fix it? How did you fix?
Hello, hello, hello. Are you able to hear me? Anish, Riyadh. Hello, Mr. Riyadh. Are you able to hear me? Hello. Okay, might be you are not able to hear me. So let's. I'll just try to complete this. So here, uh, just so what we did here. Hello, are you speaking? Hello. So let us just summarize this what we did so that we can complete. So in the buffer we have a one producer. Producer we have a, can say, list of object. First we are getting the object of list and checking list have a size 1. That means we have to wait. And once waiting done, if someone consumer consume the data, then again come again say, hey, give me the list of object again. I am going to add data, and after adding, I am going to notify someone, hey, someone go, and I'm just releasing log, someone go and try to consume data. Consumer come, consumer, if the first case consumer is empty, that consumer is waiting on the list, and once consumer if this list is not empty, then do come out and say, hey, list, I'm getting the log and getting the data from the list and removing the data and just writing the here and just say list dot notify. And if you run, you notice the producer producing data and consumer consuming data.
Yeah, did we lose the video?
Yes, we are here. Video is still going on, right?
I don't see the video.
Yes, recording going on. Okay, you are.
Oh,
Oh,
I mean your screen.
okay. Sorry, I am so I'm just stop. I'm just explaining. Okay.
Okay, okay, now I got it.
Are you see my screen?
Yeah, yeah, now I see.
That's good. So I'm just trying to say, hey, mm, this is our buffered, and now this is the producer, this is the consumer. So what
Right,
in the buffer say, ki whatever buffer be one object list, right? In this list, and we are going to one data, one thread going to write data list a list, and one is going to read from the list, right?
right,
So the producer method means they are going to write data in the list. So I am saying ki before writing, we have to check if list have already one element. Don't write, right? That means we have to wait. So I say
right,
first check the log and check the list is still size 1 or not. If size 1, that means we have to wait until someone consumer going to consume your data, right?
right,
So let's consumer get a chance and consumer say, hey, list is not empty, not empty. Get data from here and remove the list. Remove means we are getting data and removing, right? And
right,
say notify, because why notify? Because these threads are waiting here, right?
right,
So now this thread get notification come out and we say, hey, I need the list because I'm going to write it on the list. Say, hey, hey, get me lock of the list. I'm getting the lock. Okay, I'm going to add value and say after that I'm going to notify. Why? Because might be if this is list empty, then this consumer threads, if list is empty, they're waiting on the list object, right? So we say,
Right.
hey, someone waiting for me, I'm going to notify them. So this waiting threads get notification. Okay, then I can say, hey, give me the list log. I get the log and remove the data and just print data and notify them. So in this way, both are waiting notification happen threads, right? And you are
Right.
getting the output like both threads. This is thread ones producing data and consuming data, producing data and consuming data. Look, list type of only one always remove zero, right?
Right.
So in this way, both threads are communicating to each other on the list object, right? So this way, wait, notify, yes, synchronization work. So till now, number of times they are sequentially going to produce, consume, produce, consume, produce, consume, going to, right?
Right.
Like yesterday, the same program producer consumer we written using the flag, boolean flag, right? True, false, and waiting logically. And here we are using the same program, just using the locking and unlocking mechanism, right?
Yeah.
So here, getting the lock of list object and getting the read whenever we are writing data and whenever we are reading data, right?
Yeah.
So this is the way synchronized block use. In this way, you can complete block. Even you can say complete this is synchronized method itself, right? Even you can say simply synchronize this method itself. Here you don't need write this, don't need. So the also sometime euro, right? This way directly. But you say this method is just accessed by any one thread, right? And even here, Salo. This is the complete method level lock, object locking, right?
Right.
Here, in this way. I just here say synchronized and run this code. So we have to as visible possible. Okay, this is the, but we are not getting the lock up here. We are not getting a lock, right? So this is again the producer produce, consumer consume, right? This is the problem. Because current thread is the current thread is the illegal asset exceptions from this line, because here I am not getting the lock of list. Then we have to simply say not this. Simply say wait. Okay, wait. Simply here say not here say notify. I think here say notify. Here say just wait. Wait means
Oh,
now
you
we
are
have a complete object level lock, right? Complete method, right?
sorry. This is a different example.
The same
This is,
example I'm trying to say you can write synchronize as a method level or synchronize as a block level, right? Not now it's working, right? So we have a
okay.
both
See.
because whenever last class say synchronized can use in the both model. One is the complete method level, another is the partially as a block size, right?
Okay. So
So
right now
this
you
way
put it on the method. On the
method level.
method.
So whenever you are putting in the method level, that's also work fine for us, right? But
Mm.
general preferable way, you avoid method level and try to use as possible the code which you want to only block, right? Here complete code is the block, right?
Right. Right. Right.
The preferable way, if possible, we can use this synchronized block until you
Synchronous.
want, right?
Okay. Yeah.
So this is the preferable way, but you can use the both way code works. Maybe at the method level synchronization or the whenever you go to method level, then you have to directly use the only wait, not the list dot wait, because you haven't lock up the complete this object, right? Object out itself buffer, right?
Got it. Yeah.
This is the object level lock going on here. Here, I'm not going to complete object lock. I'm just a specific list. I want a specific list to add list to size, right?
Right.
So both way you can write the code, right? Maybe at the method level, that we just say you can just stop them buffer, just duplicate. I'm just written both kit for reference, right? And whenever just uh, buffer object level lock, method level lock, and just say new class, just change, and here say if you are going to the method level, just don't need to this, just simple line, right? Code will be like a here. Why they commented this code? Hmm, hmm, hmm. Just comment this two line just needed, right? Just remove this commented. I just I'm removing it, right? Your code becomes so simple, right? Right here.
Right.
So now your method level log, just check and wait, and after that's come out and notify all. Okay. So here just place the synchronize here, right? Only one. Here similarly, you have not needed, not needed, not needed, and this is your complete code, right? So this is for the complete method level, your okay method level, and this is the buffer. And here, if you want to block level, that means this is the here you have to write this, and you have to uncomment. Means you are going to a specific object here lock, right? A specific object, not the complete. So here you have to uncomment, right? Here you have to uncomment, remove this, uncomment, uncomment. Okay. So if in the case of block wise, you can also both we have a means ki options you have. So generally, guidelines say always possible you can use the block level synchronization, which code you want to lock, right? But sometime complete method you want to lock, you can do both. We have a tool option where you are going to use tool. That's you take decision, right? So this is your this code using the synchronized block wise, right? Just block of code you synchronize. Okay, and just let's test both work or not, right? So if you run here, it is work as per expected. Okay, okay, some extra line somehow. Yes, and copy paste sometimes extra curly brace come out, right? So in this way, producer produce one, consumer consume, producer produce, consumer consume. So this is the way where you are using the complete method level, your complete method synchronized, right? So that at a time only one thread can go here. Here only one thread can go here, right? So this is the complete producer and consumer problem using the method level synchronization, right? And sometime no, I'm not interested. I'm only interested in the block wise. So here, let's say block. And here say, let's create one more object here.
Yeah.
Producer block. New. Okay. Oh, oh. No, I am written somewhere the right place. Wrong place. I say this is the producer. I am written somehow. This is the buffer class. And here it should be closed here, this class, right? And here it should be closed here. So sometime you write the class inside class, it also works. But here now let's similarly you can start using the same way. Here you stop and just pass this, okay?
Right.
Block wise code, and just I comment it out, right? Okay. Hmm. I can use this buffer again here. Mm. Why happen? Because our producer class are accepting only buffer. So you cannot write two mode clause. Just as of now, just I'm renaming it so that both code can work, right? Instead of that, right? Again, I have to copy paste both. So instead of writing this, I simply say, hey, go here, and I'm just commented this code, right? For testing purpose, I say this is the buffer one, and this class say ki buffer, right? So now this code going to work, right? Object level. So here just I'm using the buffer. Buffer means this is the buffer class, and we have a complete object level block level synchronization, and run it. So both case you have means same way, right? So generally preferable way always you write the synchronized at the block level, but method level also work, right?
Right.
In this way, this is the method level. This is the method level synchronized, and this is the block level synchronized. Both are the same thing. Just block level, you have passed the which object you want to take a block, right? Here I want to block on the list, right? Okay.
Yeah.
So till now, any question, doubt about this keyword like synchronize means getting the lock of the object, right? Here, wait
Right.
means just waiting, and again get the lock, do something, and notify means now I'm releasing this lock. Someone going to take and use this list object, right?
And how do you release the lock after that
Once
line?
this once this block uh, go out, uh, lock is automatically released here.
Okay. Okay.
In the case of synchronized method, once this method complete, right, this method complete, lock is
Right.
automatic release.
Okay. Okay. Mm.
So let's say tomorrow we're going to read the same problem using the lock interface, where as a programmer manually get the lock and manually release the lock, right?
Oh, so that's yeah, that's a different way. Yeah,
Right. Yes.
we use the interface. Okay.
So by default, we are using the synchronize as a keyword. Keyword automatically work on the basis of closing of your curly braces. This is the word, right? Where the
Right.
curly brace close, lock is automatically release. In the case of block, where the curly brace close, here automatically release the lock. Here
Right.
automatically release the lock. So once this curly brace going to execute, closing of this, automatically this lock of the list is released, right?
Right.
Okay. So any confusion?
No, that's all.
Good. So let's try this producer consumer problem. You can write using the synchronized keyword.
Right.
The two format may be method level synchronization or block level synchronization. And also we have to understand thread communication between the two objects using the wait and notify, right? This
Right.
thread
Right.
say, hey, I'm going to wait. And someone they say, hey, notifying are you come and print the work, right? So in this
Right.
shared
Right.
object, sometime I'm what thread do something and going to the wait, and some thread come do something and this thread notify, hey, it's a go, right?
Right.
Once
Need some
notification,
more practice on this domain.
yeah,
Yeah.
just like as usual, these are the threadings have a different types of theory, situation, context applicable. For those cases, different technique available how to address them, right?
Yeah. But multi-threading is very different than other what we discussed.
Here, multi-threading is not different. Whatever till programming you done, just here we have to first things your use case, right? What
Right.
the things you are going to address, right? And accordingly, we have to just intimate your Java virtual machine. Hey JVM, I want this thread sometime wait, sometime get lock, and then do work. So
Okay. Okay.
doing
I
work
see.
is very simple. Here what are doing? Here simply this is the programming, right? We are getting data from the list, right? This is the only code,
Mm.
right? And all others are just the how our thread work, right? And here simply what are doing? We are just writing data in the list so flatly, right?
Right.
These things like wait, notify, synchronization just is the infrastructure where you are directing, hey Java virtual machine, this is the two threads. In this way, you can direct how they work, wait, right?
Right.
But here we want our threads is work depend upon the my workflow, not by default workflow, right?
So synchronize is a method.
Synchronized is the keyword,
Oh,
not a.
because you put it on the bracket.
They are synchronized means they are going to get the lock of which object. You are telling that
Oh, okay, okay. I see,
this
I
is the
see. Yeah,
list
yeah.
object I am going to take this is the list, okay, and I am going to first take off the lock of this object, right? So here
Right,
you can
right.
pass
Got it.
any Java object, maybe this, maybe list, maybe math, and maybe anything. So whenever
Got
you
it.
see
Got it.
synchronize block, you have to pass the object on which you are going to take lock.
Right,
But in the case of method, here method question key, why, where they are going to the lock. This method is called from this buffer object. Notice you say new buffer, then calling this method, right? So
right,
the buffer object itself, they are getting the first lock, getting the lock of buffer object. Then you allow ki, hey, call me produce method. So notice this buffer, this produce method is called by from where? This is called from the thread, right? This is my
right,
threads.
right. Hmm.
Where? This is my threads. They are calling this produce method, right? So
Right,
whenever you're going to buffer dot call produce, a produce method say synchronize, right? Synchronize, right? So synchronize
yeah,
say, hey, here say buffer. What the click? Whenever this is the producer thread say, hey, I'm going to the call produce method, yeah, consume method. So they need the object. Notice this is the object. The, this object first get the lock and then allow you can call this produce method. And this is your method produce, right? This
right,
produce methods first acquire the lock of a buffer class and once get the lock, then allow to call this method. Once this method is completed, then he release the lock, right?
right,
So both synchronized as a method require the lock of your object itself, right? But in the case of synchronize as a block of code, you tell, hey, because this here you can write anything, any object. Maybe I want to complete buffer, you say this here, okay, here this also
right,
work. This means the current object. I You say no, I don't want to take the complete object lock. I just want to this list lock. So I say list, okay. So here you can just fine grain our scope, right? So notice your object have a some bigger value, bigger operation, 10 methods, 10 something. You get the complete object lock means ki at that time only one threads are calling these methods. All methods are, if any new threads come and try to call this method, they cannot call because you already get the lock of this method, right? Class.
right,
So other methods are still new method, but no one can call your method because you are taking the lock of complete object. And whenever you go to synchronize as a block, you say this class have maybe 10 method, but in this method I'm only specific call the specific, they have two object, maybe list one, list two. I want to only get the lock of list one, right? So
right,
only list one can be blocked by other threads and all other method any one thread can call, right? This object lock is open, free for other thread can call, right? So sometime you can say block level lock is a fine grain lock, means limited, very small scope. But whenever say key method level lock, that means your complete object are going to the lock for some period of time until your method or your thread not release the lock.
right,
So this is the time performance. You are just you want our object can be multiple uses happen. Then generally we are focusing as a block wise, right? As small portions you are locking, right? Rest bigger
right,
portion of the object you are releasing them, right? Allowing
right.
them multiple thread can access, right? Let's do practice, and if still any confusion doubt, we'll discuss. Right?
Sure. Thank you.
Take care.